So I think it helps to, I'm not sure how you solve problem set 2 yourself, but it helps to break the problem into stages. So we'll think of a first stage where we just declared we're going to have a certain quantity of this good. And in the first stage, we want to figure out, well, how do I want to acquire that good? How far do I want to go toward reducing its price? That's the H decision. And then once I made that decision, I know what my price is, and then I buy Q times P. And so we have that. That's what I referred to a sub-cost function. E will be our sub-cost function. And it tells us what it costs when we're doing our best to finance a given amount of Q. And then I will also, in the notation, refer to H of Q. You can think of that as the policy function. What is the optimal H that achieves this minimum cost? And that's going to have, as a cost function, it's going to have the various cost function properties. A kind of envelope theorem property that the slope of the cost function is going to be equal to the price evaluated at the optimal investment. And it's going to, this cost function is going to be concave, weakly. And particularly the strict version is what's going to generate a lot of the interesting results here that we don't have in the more usual supply and demand analysis. And then the second stage will be, well, okay, let's just take this E, then that's what it costs to get Q, and make our decision, well, how much do I want to have of Q versus all the other goods? And if E were linear, this would just be our Marshallian demand type of problem that Murphy did in the first week. But the interesting case is E is going to be concave. You're inquisitive, so let's hear it.
It's the concavity of E that causes the increase in return scale, right?
Yes. We're going to see in a picture here, and it'll be, I'm a geometry guy, it'll be more vivid, I think, in a picture. Here we go. Here's a picture. So this is in the commodity space. I want to graph the quantity Q versus the quantity of all the other goods. And with this budget set arrangement, we'll start with Y. Y is the person's income. Of course, they could spend all their income on all the other goods and then none on this good. That's a point on the budget set. But then as we move away, we move to the right, we're going to be moving down. How much are we giving up? Or we're giving up according to E. E is what it costs to have Q. And so that's what I've graphed here, Y minus E. If you don't want any Q, then Q would cost nothing. And the more of Q that you want, we move down. And instead of it being a straight line like Murphy showed in the first week, it has this now it's convex when we're subtracting. Now let's suppose the person's choosing here. We need to figure out where they're choosing. That's, of course, part of the analysis. But suppose the person's at point A. What can we see in this picture? Well, we can see that the slope is the price. The slope is negative, but the magnitude of the slope is the price. Which price? Well, the price that corresponds to the optimal investment for achieving that consumption at point A. And so when we project that back to the axis, we can see, well, how much of the guy's income is he spending on this commodity, on the variable cost of the commodity, if you will. And you can see that. We can also see by going all the way up to Y, how much he's spending on the fixed costs, how much he's spending on the H. So we can see that in this picture. And of course, the third thing he spends on is on the other goods, and we can see that as well. So we have one picture, and we can see all those three quantities.